So yeah, so the deployment strategy for any kind of machine learning algorithm will be the quite similar. There is a no difference in the deployment, but yeah, if you guys facing any kind of problem, then feel free let me know. But as of now, just try to understand what is decision tree. So today agenda is to understand about the decision tree, complete mathematics and complete architecture of decision tree, how decision tree works, and how the things is getting work in the production as well, and when we should use which kind of algorithm. And there is a many question will come on a way, but we are not going to take care of all those things right away. But at first, let me complete the decision tree. And in going forward, if you face any kind of problem, any questions, feel free, unmute yourself, and you can ask the question, right? So, but before proceeding any with the algorithm, let's first discuss the life cycle of machine learning model. And this diagram explain the creation of machine learning model from the scratch, and then taking the same model further with the hyperparameter training and increase its accuracy. Deciding the deployment strategy. So you can see this same strategy we have learned in linear regression and logistic regression as well. So from where we are going to start, we are going to start taking the problem, and then we are going to select the data. What are the data we needed to solve that problem or to build the model, and data descriptions. What is the data is saying? Each features. Whenever we are going to build a model, there will be some feature, input feature. What are those input features? How the features is getting defined? What? Let me close my door. There is some. Much better now. Okay. So everything we are going to learn, like what are the data needed and what are the input features to build that model, and what is the definition of that feature, those features, how those features works, what are the things we needed, and what are the feature engineering we have. Okay. So, hey, hi, Satisha. So yeah. So yeah, we just started the decision tree classifier. Today we are going to learn about these things. So we were just explaining about how the deployment in the previous classes so far. So far we have learned linear regression, logistic regression, and different deployment strategies we have learned. And today what we are going to learn? Today we are going to learn the decision tree classifier. And in the decision tree classifier, same things we are going to do. What are the things we have done in the linear regression and logistic regression, like model building and then model deployment and then model monitoring, model retraining, all the sort of things we have to see. But before that, let's discuss about a decision tree. What is the decision tree it is? So before starting the decision tree as well, I just love to talk about how the model is going to move into the production. So for that, first of all, we are going to take a problem statement from our stack, and that problem can come from the anywhere. It can come from your stack. It can come from your product manager. It can come from your tech lead. It can come from your business side. It can be anything, and the problem can be anything. It can be medical domain. It can be more about the engineering domain. It can be anything, right? So, and it can be something like natural disaster related problem statement, right? Like Titanic incident, right? So Titanic is also kind of natural disaster is there, right? So what are the problem? What are the what are the causes behind of that problem that occurred, and what are the survival rate was there, and who got survived from the Titanic? It's a multiple input features will be there to solve any kind of problem. So first of all, take a problem statement, understand the problem very clearly, and make a notes what the problem you are going to solve. Then we are going to select the data. Let's suppose we are going to prepare a data, means like as soon as we identified the problem, then what else we have to do? We have to, we have to select the data set. Like you cannot select any kind of data. It's something like you have to select a very precise data which can eligible to solve your use case problem statement. Your problem statement, it will able to solve that part we have to do. Then what we have to do, whatever data we have selected, that data must say something. The data used to say something. Okay, this is the input feature, this is the output feature. Each feature's definition you have to make understand. Like, okay, So let's suppose we are taking the example of Titanic survival. So it can be possible. What are the different features are there? Like, okay, if the gender is male or female, then the survival rate is high for the male and female survival rate was low. So there is a directly you are getting indicator. This is called direct indicator whether people can survive or not. Number one, gender. Then it could be possible what is your age. It could be possible if your age is between 20 to 30, you could survive. But if your age is below 20 and above 30, you could not survive. This is also indicator. So each features are important, right? So that is again coming into this picture. Now, what we are trying to do, we are trying to perform some kind of statistical and graphical data analysis in this section. And here our those things will come into the picture, like standardizations, normalizations, and bell curve curve is getting performed or not. This kind of thing we are going to understand in case of performing both statistical and graphical data analysis. Here also we will use some kind of library to visualize our data set. We have seen in our linear regression and logistic regression very clearly. And then we are going to perform data transformation and derivations of new attribute necessary, if necessary. Means let's suppose sometime what happened, what we understood, some feature will not be defined directly. You have to prepare that feature. You have to prepare those features, and to prepare those features, how we are going to prepare those features, that features are not directly defined by your data set, whatever data set we are collecting. It could be possible the combination of two input feature, you are going to generate a new feature that is called something else. Like that feature is coming a part of feature engineering. So that part we are going to perform in this section, data transformation and derivation of new attribute if necessary. And then what we are going to do, we are going to selecting the machine learning algorithm based on the pattern observed in EDA. Okay. And then what we are going to do, we are going to perform data standardization and normalization. And then we are going to perform the create and train and test split data set. Why we needed this train and test data set? Because whatever model, so let's suppose after learning, you have to go for the examination as well, right? So whether you are able to crack the examination, that's a matter, right? If you are learning but you are not able to crack any interview, then it's no use at all, right? So for that you have to crack the interview. You have to crack the interview. If you are able to crack the interview, then only I could say like, yeah, you learn better. But if you are not able to crack the interview, it's nothing. So for that reason, what we are trying to do, we are trying to prepare our training data set and then test data set. So we will learn training data set, and then how we are going to evaluate my learning. We are going to use the test data set, which is also known as the unknown data set, which you never see. And that data set, on top of that data set, we are going to pass our model, and we are going to check how my model is getting performed. So for that reason, we need this question, which is called create a train and test set using the optimum parameter. And then what we are trying to do, we are trying to perform the model training using the machine learning algorithm. And here we can see up to from here till here, we are going to use the same stage for any kind of machine learning. Here, model training using the machine learning algorithm, that part is quite different for the model to model. If you are using linear regression, the linear regression model you have to select. If you are using the logistic regression model you have to select. If you are using decision tree, then decision tree or XGBoost, AdaBoost, SBM, support vector machine, KNN, whatever model we are going, whatever algorithm we are going to use, we are going to select that algorithm in this section. And then what we are trying to do, we are going to, as soon as model training has been done, then what we are going to check, we are going to evaluate our model with the help of different kind of metrics. Again, if it is a linear regression problem, metrics will get changed. If it is a classification problem, then metrics will get changed. So with the based on your use cases, the metrics to evaluate your model will get changed. Okay. So if you are using like a classification problem, if you are solving the classification problem, then your accuracy in that case, the evaluation metrics will be accuracy, ROC, AUC, okay, and F1 score. These kind of metrics will be there to evaluate your model. Similarly, if you are using the linear regression, then what? Then R square, okay, adjusted R square. These are the metrics we are going to use, right? So you guys can understand this thing. And then what we are trying to do, we are trying to use the hyperparameter tuning and achieve the better accuracy. Again, we train the model, but we found that our model still can perform better than the current model. So what we can do, we can do the hyperparameter tuning, means whatever the hyperparameters are there, we can use those parameters and we can start retraining those things. And then we are going to save the model, and then we are going to use the deployment of the model. And if deployment of the model can be different way of the deployment of the model. Number one, let me write down. So again, I have already speak about in my last session, but again, I'm going to explain the deployment strategy. There is a different way to deploy machine learning model. It depends what is your use case and what your stack asks for. Number one deployment strategy is real-time inferencing. Real-time inferencing. And number two is called batch inferencing. Number three is called serverless inferencing. Let's talk about each and everything one by one. Okay, again, these are the things is coming under this stage. And again, these things you no need to take care, because these things is getting done by a specialized of ML ops engineer. These things is not getting done by data scientist or ML engineer. These things is getting done by the ML ops specialized person. But as a beginner, you should know what are the different types.
I have a note of a not related what you're telling. May I know the roadmap for the data science and data analysis?
Okay, you want that roadmap, how we can get proceed, right?
Yeah, to be in a data analyst or data science.
Okay, these roadmap I think I already given in my first class, but I can provide you. I have that notes. I will send you DM. Okay.
Okay.
Yeah. So yeah, again, I'm saying, if you are looking for full stack data scientist, you should know each and everything. What are the things is here? What are the things is also will come in future, right? So these are the different type of deployment strategy. Number one is the real-time inferencing. Number two is the batch inferencing. Number three is the serverless inferencing. Let's talk about each and everything so that the things will get clear. Real-time inferencing means what? One machine, let's suppose you have one machine. That machine is running 24/7. 24/7. And whatever request is coming to your machine is going to give the response. This is called real-time inference. Okay, your machine will run 24/7. Now coming to the batch inferencing. What do you mean by the batch inferencing? Let's suppose you know your machine company knows when our volume is coming, or maybe when when we have to do the inferencing, or we can store this inferencing in our DB and later on we can use it out. So in that case, we can use the batch processing. Batch processing is useful. Like let's suppose you want to do the inferencing only on morning time. So why you want to keep up and running your machine 24/7? Only run your machine on the morning for 2 hours and let turn off this machine, so that you are not utilizing this, you are not wasting this resource. You are going to utilize this resource, and also you are doing the cost cutting. Only 2 hours is running and it's doing their job, right? So here you are saving 22 hours machine involved here. So this is also a important deployment strategy, but again, it's not suggestible, because see, let's suppose in your use case it fit, like okay, 2 hours is running and our job is done. But sometime what happened, it could be possible, like your means I have not seen practically some inferencing is getting done in the batch processing. It depends it depends on the use case to use case, but again, in real time, no one is preferring this batch processing. Okay, but it could be possible to do the batch processing. If your use case is saying okay, you can do the batch processing only for 2 hours, you can keep your machine up and running for 2 hours only in the morning, and you do your job, turn off the machine, so that you are saving the cost. Third strategy of deployment is coming as serverless. What do you mean by the serverless? Server means what? Server means machine. This is also server, this is also server. Here server is running 24/7, here server is running 2 hours. What do you mean by the serverless? Serverless means you don't have any machine, okay, and it's not getting managed by you. So whenever you need it, let's suppose you want to type one letter, so what you can do, you don't have the laptop, what you will do, you can go to your friend and you can borrow his laptop or her laptop and you can do your job and you can get back the laptop. Did you paid anything? Or you can pay for rent as well. Okay, in cafe also we used to do, whenever we needed, we used to go in the cafe, internet cafe, and we used to do our job and then paying them and coming back from the cafe. This is the same thing. So serverless is also doing the same way. I'm not keep my machine up and running 24/7. What I'm trying to do, whenever request will come to my inference endpoint, it will find any machine in the cloud, any machine. It's not like a dedicated machine. Any shared machine. Shared machine means anyone can use it. So it is going to find any kind of shared machine, and shared machine do their job, give the result to client, and then again this machine is going to utilize by the other request, and it is getting idle once. So here you paid only for those requests, whatever request is coming, as soon as request completion is done, request processing has been done, it is going to relieve this machine for the further execution or another execution. This strategy is called serverless, and means 90% of startup are following this approach only, which is called serverless inferencing or serverless deployment. Nowadays, all the backend front-end deployment is going on the serverless only, and even machine learning model is also going on the serverless. But there is a means limitations in the serverless deployment strategy as well. You can't, you can't deploy those model which is, size is more than 5 GB. That those model we can't deploy. We can deploy only those model which model size is less than 5 GB. Then only we can deploy this model as a serverless. If your model is bigger size, then you have to go in the real-time inference, right? So we can't go in the serverless stack. Okay. So did you understood the different type of deployment strategies, guys? Any question?
Yeah.
Nice. Yeah. Any question? No. Okay. So again, this part is no need to take care by you, but good to know what are the different type of deployment strategy. It's very common question in case of interview. Next, we are going to finalize the retraining approach. Okay, it's see again in machine learning or in AI field, which is called detourization. What do you mean by the detourization? Detourization, let's suppose you are buying a car. With the time, car price will get reduced or increase. It will always reduce, right? So it is called depreciating asset. Car is also called as what? Depreciating asset. Means you bought a car with 20 lakh, and with the time, after 10 years, the car price will be 2 lakh or 5 lakh. It will never go beyond the 20 lakh. Right? What I'm trying to explain you, are you guys able to catch it up? What I'm trying to say? This is called depreciating asset. That's what car is also known as depreciating asset. Right? Similar case is also applicable in case of machine learning model as well. So machine learning model as well is also known as depreciating model, depreciating asset, you can say. So with the time, model performance will get reduced, will get degraded. So we always have to retraining approach. We always have to follow some retraining approach, and we can go ahead with these things, right? And then, so we have to do the retraining. Similarly, and after the retraining, we have to do the login and monitoring the model performance so that we can do it. And then dashboarding and monitoring. Here the Tableau and Power BI will come into the picture, and here we are going to stop this process. So this is very common process for any kind of machine learning model, irrespective of any kind. Like if it is a linear regression or logistic regression or decision tree, SBM, KNN, XGBoost, whatever model we are going to learn come in our coming classes. In all the classes, these things will be, will be common. Only thing is that what we are trying to change this model training and evaluation. See, if your regression problem, the evaluation metric will get changed. If your classification problem, then again evaluation metrics will get changed. Model will get changed, evaluation metrics will get changed. So you have to take a decision by you. This is your call. Then apart from this, everything will be common, right? So yeah. Now let's begin decision tree. Okay. So forget about what are the things you learned or whatever classes you missed it out. Just focus on this class and today take a promise with yourself. You guys will complete the decision tree classifier at least. Okay. So afterwards, the things is very common. Now, what is the decision tree algorithm? Decision tree algorithm is one of the most versatile algorithms in machine learning, which can perform both classification and regression problem. I think this is the very common question, and I should not answer what is classification and regression problem, right? It is very powerful and work great with the complex data set. And apart from that, it is very easy to understand and read. I can explain this part. Why I'm saying it is very easy to understand. That make it more popular to use. When couple the ensemble techniques, there also we are going. Ensemble means what? We are going to combine the different kind of machine learning model in a single model. That is called ensemble. Ensemble, let's suppose you are going to make an ensemble computer. So what we are trying to do in case of ensemble, we are buying CPU from the different company. We are buying hard disk from the different company. We are buying some RAM from the different company, and we are getting put together all those things in one place, assembling it and making a single system. This is called ensemble techniques, right? So similarly, in case of in the case of machine learning also, there is a one techniques is coming into the picture, which is called ensemble machine learning. So what we are trying to do in case of ensemble machine learning, we are trying to gather different kind of machine learning and putting together in a single place and creating a single model. This is called ensemble. So in case of ensemble machine learning also, we can use what we can use. So we can use sorry, we can use the decision tree as a single model, as a separate model. Or you can say decision tree works as a hard disk or motherboard or RAM. It can be anything, right? So how the decision tree works? Let's suppose, and I'm taking a very generic example. Don't take it stress on your mind how decision tree works. Okay, take it a very simple example. Take a very generic problem statement and then try to solve this statement with the coming use case. Okay, so let's suppose today is the Friday, and generally Friday is my weekend. I always used to say to my colleagues, my family, my friends, everyone, Saturday, Sunday again my working time. So Friday I used to means after this class I'm feel like okay, it's my free time. I can use my time to go somewhere and do some go for dinner or go for some outings I used to do on Friday. So let's suppose 1 minute. So let's suppose on Friday night, my friend came to me and he asked, let's go outside. Let's go for dinner outside. So what I will do, I will check first thing whether I have completed my class or not. Means, okay, I have completed your class. Then what I will do, I will check what is the timing now. If my night timing is more than 10 p.m., I used to generally avoid to go outside at night because like I don't like driving in night, to be honest, because I have my vision problem. So I don't prefer to go outside. Means after 10 p.m. So I generally avoid. Or if I'm going also, then I used to prefer cab. I don't drive self. So this is my strategy to go outside. And also I believe to go with the safe drive. So what I will check, there's a different condition. Number one condition, what is the timing? If the timing is more than 10 p.m., then I will not go. I will not go. Then second, if timing is if timing is more than 10 p.m., then I will check the further condition. And if the timing is more than 10 p.m., then I will don't go. Means I will say no, I don't. Right? Second condition is what? Second condition is what? Even if time is not more than 10 p.m., 10 p.m., then what I will check? I will check, do you have enough money? Means it could be possible you time is less than 10 p.m., but you don't have the enough money. Then I should, what I will do? I have enough money. I have enough money. What happened? Just a minute. So yeah, do you have enough money? If yes, go and enjoy. If you don't have money, then don't. Okay, so these are the different strategy we are in real time. Also, we used to make a decision like this only, right? So this is the simple use case I have taken example. First of all, tell me how many of you guys understood this problem statement?
Understood, sir.
Yeah. Now here is the problem. Problem is what? Problem is there is a node. What you can see, there is a two node.
There is a two choices. Like
Yes.
if you have money, you can go. If you don't have money, you don't need to go. The first condition is if that within 10 p.m. then you are about to go. If 10 p.m. exceeds, you cannot go because you have eyesight problem.
Correct, correct, correct. Now here is the one problem.
So
Just
each and every problem, like what you said in earlier, for every problem solving, we need to come up with everything points and key points based on that we need to choose how the problem, how to solve it.
correct, correct, correct.
Yes, yes, yes.
Correct, correct. This is called decision. So now here is one problem. Just try to understand. In real time, also this happened. Generally, it's happened with me as well. Okay, the problem is what? Which node you have to select as a primary node. Primary node means you can select, do you have enough money wala nodes at the first place, right? And then can check that whether what is the time. That is could be possible. First, you will check your, do you have enough money? If yes, then you will check what is the timing now. That could be also possible. Yes, no.
Yes, sir.
Now, here is the actual question is coming to you. So you can't select randomly any node as a primary node. I will tell you why. So let's suppose you have enough money. You spend some time to take a decision to check whether you have enough money or not. And then even if you have enough money and you are checking the time, okay, time is more than 10 p.m. You are going to discard. So why cannot check this timing at the first place and then check the enough money or not? Means here you are going to reduce the complexity. Means what we are trying to do, if your time is not less more than 10 p.m., you will not check whether do you have money or not. Why you have to check? You are going to discard your plan there only. Right? So
Rajesh, can I give an example with my previous work?
yes, yes.
For example, if I'm getting different kind of cases reports, in that I need to separate what is the exact report. For example, to find out pathology report means I will keep some keyword. If that keyword is present, then it will go to yes. If not, it will go to no.
Correct, correct.
And
Correct.
second parameter, what I am going to check is whether the report which is what they have submitted, which is generated in last 3 months, it will be yes.
Yes.
It will go for the further step. If not, means it will go to say no and we will be asking some queries on that. Like that, we need to write our code based on this parameter.
Correct, correct, correct. So that's what I'm saying. You no need to write a code for this. That's what model is coming into the picture. But I'm just trying to explain you how the model is working at the back end. For this model we are going to build, but model will work like this. Now, so you understood, right? So with the stages, means this is called primary node, this is called child node. So if you cross the primary node and reach into the child node, the complexity or to take a decision should get reduced. That's what I'm trying to say. But after coming from the parent node and you are reaching into the child node, and if you are increasing the complexity, means this is not a right decision maker. That's what I'm trying to say. So with the moving procession, like from parent node to child node, if you are moving from the parent node to child node, the complexity to take a decision should get reduced. These things only keep in your mind. So to understand, so we understood this is the very simple use case, and here only we understood the problem, right? To which node I have to select as a primary node, which node I have to select as a child node. So for that reason, we are going to learn two things, which is called number one, Gini indexing, and number two, called entropy. Hold on, I will talk about these things in in coming slides. But as of now, just try to understand this also. You no need to worry about it. Which node I have to select as a parent node or which node I have to select as a child node. For that, we have a Gini indexing and entropy concepts are there, which can help you to take a decision which node you have to select as a primary node. Did you guys understood now? Any question?
Yes, sir.
Cool. Now, here is some points I have written. Although we may or may not use the decision tree for such decision, this was the basic example to help you understand how the decision tree makes a decision. So how did it work? It select a root node based on the given condition. For example, our root node was chosen as a time more than 10 p.m. Then the root node was split into the child nodes based on the given condition, and the right child node above figure fulfill the condition, so no more question were asked. Okay, so 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 the left child node didn't fulfill the condition, so again it was split based on the new condition, and this process keep continue till all the conditions are met, or if you have predefined the depth of your tree. For example, depth of your tree is 3 and it reached there when all the conditions were exhausted. Let's see how the parent node and condition is chosen for the splitting the work. Okay, so now we are going to understand the major problem of the decision tree, how we are can able to select which node I have to select as a primary node. So hold on, hold your breath, and I'll talk about the decision tree for the regression. I'm just talking about right now decision tree for the classification problem statement. Okay, but we can use for the regression problem as well. And how many of you know what is regression and classification? Don't ask this question again. Any idea? Any idea? Decision tree classification and regression problem? If you don't know, please let me know. I can help you to understand.
Have you come across this in previous classes?
Yeah, in previous classes only I have taught you.
Yes, heard it, but as I'm
Okay, so regression means, and what about Rupa? Rupa was joining, I have seen. What is regression and classification, Rupa?
Yes, sir. I know, sir. I got the once and I do.
So see, this is the very basic thing I could say. If you join the class, then respect the timing of the trainer, respect the timing of yours. And I don't, tolerate this kind of behavior. Again, I'm saying if you're attending the class, this is very basic thing. Very basic. I'm I couldn't remember like from the beginning of today's session only how many time I have repeated this word regression and classification.
Sir,
Regression and
regression is a statistical technique, sir.
sorry.
Regression is a statistical technique, sir.
No, it's not a statistical technique. Okay, let me first explain you guys first. And you guys are not saying at all any question like what is regression classification, right? So see, let's suppose if I'm saying your height and your weight. If your height is 2 feet, your weight is 10 kg. If your height is 2.5 feet, your weight will be 10.6 kg, right? So this kind of problem statement is called regression problem statement, where let's suppose this is our output. Weight we have to predict. Means let's suppose my height is 6 feet. What will be my weight? It could be like 75 kg, 70 kg kind of, right? So with the height, you have to predict your weight. And the weight can be anything. 75, 75.5, 76, 76.6, 77, 77.7, kind of anything. So if you are dealing this kind of problem statement, then this is called regression problem statement. This is called regression problem. Now coming to the classification problem statement. Classification means what? Let's suppose if you are studying 2 hours in a day, you are getting fail. If you are studying 5 hours in a day, then you are getting pass. If you are studying 10 hours in a day, you are getting extraordinary mark. Extraordinary mark. This is called classification problem. It will never be between pass and fail. Your output will never be between pass and fail, or your output will never be between pass and extraordinary. Your output will never be between fail or extraordinary. Either it will be fail or pass or extraordinary. This is called classification problem. Did you guys understand now? It is clear what is regression, what is classification?
Yes, sir.
Okay, very good.
Okay, regression is a continuous manner.
Very nice, very nice. Yes.
Decision tree we can say as classification.
Decision tree we can use in both the problem statement. That's what I have talked in my very first slide. If you can go in the very first slide, decision tree is one of the most fundamental algorithms for the classification and regression. Can you see my dear?
Yes.
In both the cases, we can use decision tree algorithm, either regression problem statement or classification problem, right? So we'll talk about the how we can use the decision tree for the regression, but as of now, just focus on regression. 1 minute. Okay. Yeah. So now I'm going to talk about pruning, tree pruning. What do you mean by the tree pruning? So see, have you met any guy who is very overthinking? Anyone is from here? Anyone is here who are very overthinker kind of people? Okay, I am. To be honest, I am very overthinker guy. Like whenever I used to take a complex decision, that time I used to take up means I used to do very overthinking kind of. Okay, what will happen if I'll do this? What will happen if I'll do this? Kind of many things is coming on my mind, and it's stopping me to take decision for that particular problem. So this is called overthinking. How I can get rid with this problem. So what I used to do at certain point, I used to put a full stop on my question. Okay, now it's enough. Put a full stop and take a decision. This is called pruning. Pruning means if your decision tree is not getting finished at all, till you are going depth, how much depth you can go. You have to full stop at some certain point. That point is called pruning concept. Did you guys understood pruning? What is the pruning?
Yeah.
So pruning, tree pruning is the
Cutting of continuous population.
correct. So tree pruning is the method of trimming down the full tree and often through the above process to reduce the complexity and variance in the data, just as we regularized linear regression. In linear regression, we have seen lasso, ridge, elastic regularization techniques, right? Similarly, in case of tree pruning, in case of decision tree also, tree pruning is also known as regularization technique. Okay, so let's talk about what are the different type of prunings are there. So there is two type of pruning, which is called post pruning. Second one is called pre pruning. Pre pruning means before taking the decision. Sorry, before taking the decision, you are going to prune the data set, right? And post pruning means what? Post pruning means after decision tree, you are going to cut down the tree. Okay, so this is called pre pruning and post pruning.
Tree pruning means before going to start, we need to keep communication.
Yes. Yes.
Post means I really not understand to be in technical way.
Correct. So means, can you repeat your question? Did you ask any question? I couldn't hear you.
Yeah, post pruning. I want a new
हाँ,
technical.
post pruning में क्या होता है, like what we are trying to do in the post pruning. So let's suppose you are taking the decision, means you done the decision after asking the so many questions, and you found okay your decision maker taking more time, and after certain level, means if your question is going beyond the some certain threshold, you are going to cut down the tree, and there only you are going to put a full stop. Means what I'm trying to say here. So let's suppose in pre-pruning, what I'm trying to say, this is the tree you are going to do, and you are going to put a hard stop here at this point. This is called pre-pruning. You are going to tell your model, hey model, after the two stage, you have to stop. You have to stop. This is called pre-pruning. Now post-pruning में क्या कर रहे हैं? You are going to make a tree, you are going to make a tree, you are going depth, and you are making the decision. But you say found, okay, we are not able to take a decision after reaching at some certain point. So in post pruning, also known as the backward pruning, in this process where the decision tree generates first, decision tree we are going to generate first, and then non-significant branch we are going to remove. Means we can see in some cases, means after taking a decision, we found some of the question we asked by ourselves unnecessary. We are doing these things, right? Unnecessary question we are asking to take a decision. So that question we can cut down. This is called postpone. Now it makes sense?
Yeah.
Good. That is fine. Cool. Now actual classification problem will come into the picture. Now classification tree. Regression tree are used for the quantitative data, means like a quantitative means that number 75.5 kg, 72.2, this is called quantitative data. Okay. In this case, in the case of qualitative data, means qualitative in the sense of the classification data or categorical data. This is also called as categorical data. So we used classification tree, and in regression tree, we split the node based on the RSS. RSS is residual sum of square. I don't know. You guys didn't attend the class, I think. These things has been already taught, but don't worry. That's what I'm not touching. This regression decision tree. I would request, please go through this video. So already mentioned, I think, linear logistic regression. I think here, ML linear regression. Please watch this video.
Rajesh, for that, we need to remember all the formulas and all. Actually, I was okay till like that, but after when my semester started, I find it very difficult. Too much problematic and the formulas, everything we need to keep it in. I mean, we need to remember it.
Sorry, I'm not able to recall you. Like, can you repeat that?
No, I'm saying my concern because till Python, okay, I was there, sir. But later on, December, I'm feeling it is very difficult actually.
So what I'm requesting you,
the problems,
what I'm requesting you,
formulas, everything.
I understood what I'm trying to request you. Please go through this video first. Did you go through this video once?
The multi-threading,
Not multi-threading, this one, linear regression.
Yeah, I come across, but I find it very difficult.
At what point you found difficult? Can you help me to understand so that I can help take it?
The total process is still continuing because that feeling that we need to remember all these in formulas, everything we need to remember it.
So what I'm trying to say today, just go through this video once again. Just go through that. Just bear with the theoretical concept. Don't go in the mathematical explanation. Just go through the video, and then mathematical explanation I will take care of you once again. Don't worry. Okay.
So in general, I'm asking, we need to keep these things, everything in our mind. For in future, if I want to go in my side.
You have to keep in your mind. No, you no need to keep anything in your mind. Everything will be taken care by the library. Okay, but you have to know how the library works. No one is going to ask you to write a mathematical equation how decision tree works, how you are going to select the node, how the Gini indexing work, how the entropy work. No one is going to ask you to write the mathematical formula, but you should know how the Gini indexing work, what the mathematics behind of it, everything you have to know. Then only you can cope up with this. Yeah.
Okay. And one more thing for the data science, I have come across a fact from the PDF, which is mentioned, for even for the data science, you need to come across this ML and everything.
Pardon, please.
For example, for data analysis or data science also, we need to come across this ML, especially this logistical, statistical analysis. And
Yeah, that part you have to. That's what it's a very common thing.
not know after class or we just in a simple way, what are the essential topics to be in upper class would be becoming data analyst or data scientist.
What are the topics?
But what are the things I must know?
Okay, okay. So that I can help you, don't worry. But I would request you, please means regular with the classes. Okay. I know you have a concern like about the timings. I completely understand that part.
Because it is a 3 o'clock,
Huh.
2 o'clock, and I leaving will be sleep.
Understood, understood, understood. Got it. So what I'm trying to say, like from the next week onwards, the classes timing I'm going to change. I'm going to make it at the 7 p.m. only on the weekend. So you no need to worry. And also whatever classes you left, I'm going to start a new batch. In that batch, you can continue and you can complete recap your things, whatever things you left. Okay.
Okay. Whenever I'm getting time, I'm trying to see the videos and that.
Sure.
Yeah, I'll do it. Okay.
Yeah. Cool.
Okay.
Cool. Okay. And what about Deepa, Rupa?
Sir, today is festival, so Divya did not start.
What festival today?
Varalakshmi festival.
Acha, acha. I'm not aware about it, sorry. But I have seen like many people are not joining from the last 2, 3 classes. Tirumala used to join very continue, means like she is regular with the classes. And Prasant or Susant, I think Susant. Susant was joining deployment classes, complete deployment he attended, but again he become irregular. So I'll send a message to everyone.
He's having MBA.
Acha, acha, acha. So yeah, I will send a formal message to everyone. Please continue regular with the classes because this is important. This is also important. I'm not saying this is important. This is also important. And so because you are spending your time, you are spending your time, you are spending your money, you are spending your everything, right? So the value should come after a time. So that's what I'm requesting you guys. And also I have shared one project. Whoever joined my last class, I think Susant and Tirumala has joined. So I have shared one complete end-to-end project to deliver, and I think these guys are working around it. So uh, maybe we have to means continue with that so that you guys will get a project so that you can show the case this project in your resume. It will help you. To be honest, it will help you, right? So yeah, got it. Okay, cool. So let's begin then. So to now I told you the bigger problem in case of decision tree is what? Selecting the parent node. So for selecting the parent node, we have to understand 2 things, either of them, like either entropy or Gini indexing. It's not both the things is same job, doing the same job to identify your parent node. Which one will have to select as a parent node and child node and child to child. So for that reason, we are going to understand the entropy. I think everyone is coming from the science background. So I would ask one question, what is entropy? In chemistry or physics? In physics, thermodynamics, one chapter was there in +2. I think there you would have learned what is entropy. Anyone?
I am commerce background, sir.
Acha, you are from commerce background.
It is entropy is a degree of, for example, every molecule will have one kind of attraction. It is like outer circle, it is entropy action, and we will see.
Correct. So entropy is known as degree of freedom. I think this no need of +2 as well. Till 10th only we are going to learn. So in case of solid, molecules are very attached to each other, right? Right?
Yes, sir. Yes.
In
Yes, sir.
liquid, molecules are slightly separate to each other, but in gas, molecules are very part away. So in this case, entropy is very low because the randomness of the molecules is very less. Sorry, randomness of the molecules are very close to each other. So entropy will be minimum. In this case, entropy will be more than gas. Solid. And in gas case, entropy is very high because the randomness of the molecules is very high. Means there is a no law that this molecule is here, the next molecule will be here. It can be anywhere, right? This is called what? Entropy. Entropy means degree of freedom. This is called, actual definition of entropy is known as degree of freedom. And in this case, the degree of freedom we are going to convert is a degree of randomness. Okay. So entropy is measure of randomness in the data. In other words, it gives the impurity present in the data set. This is called entropy. So in this case, see, this is the solid structure. So in this case, you can say low entropy. But in this case, you can see the randomness of the molecules or data is very high. Where the data is getting fall, we don't know. So this is called high entropy. Did you guys understood?
Yes, sir.
Yeah. So no need of commerce or science background as well. This is the things we learn in in 10th till 10th one. So when we split our nodes into two regions and put different observation, let's suppose we are going to take a decision. Okay. So whether I should go out or not, what I'm trying to check? First, I'm trying to check what is the time, right? So after checking this time, and if I take a decision, the time is not more than 10 p.m., then I should not ask again the same question in the bottom. So what I'm trying to say, when we split our node into the two regions, put different observation. Okay. So when we split our node into two regions and put different observations in both the regions, the main goal is to reduce the entropy. Means if you are reducing the entropy means randomness you are going to reduce, right? That is the reduce the randomness in the region and divide our data clearly than it was in the previous node. And if we splitting the node doesn't lead into the same label and random, and if there is a mixture of the label present high entropy, let's suppose there are n observations and we need to classify them into the category 1 or 2. Let's say the category, say that category 1 has n observations, and category 2 will be m minus n observation. So how we are going to calculate the entropy means what we are trying to do. So problem is what? Same. Problem is we are trying to solve what? Which node I have to select as a primary node. So for that, we are going to calculate the entropy. And with that entropy, we are going to calculate the information gain. And if the information gain is high, means that node will be our primary node. If information gain is low, that node will be child node. So how we are going to calculate the entropy? For the entropy calculation formula is quite simple. Let's suppose what I'm trying to say. Just a minute. So entropy calculation formula is already given here. Minus P. Let me explain you everything. Don't worry. Don't worry about the mathematics. It's quite simple. Log of Q base 2. Okay, this is the entropy formula. Now just try to understand how the entropy works. So let's suppose we have a two category. Category 1 and category 2. So P is what? Probability of of category 1. And Q is what? Probability of category 2. Can I write Q की जगह पे 1 minus P? Can I write like this? Yes. Obviously, let's suppose you are tossing a coin, you are throwing a coin. Then if head is coming, it's a probability either it can be head or it can be tail. So what is the probability of coming head? 50%. Then what is the probability of tail? It will be for 50% because 100 minus 50 is 50%. So Q is nothing but 1 minus 2. So now similarly we are going to write. So entropy formula is equal to minus P, means probability of category 1, log of probability of category 1 base 2 minus Q into log of probability of category 2 base 2. Now just try to understand if the probability of category 1 is 100%, let's suppose the P value is 1. P value is 1, means probability of category 1 is 100%. Then what will be the probability of category 2? Anybody? Answer it. If the probability of category 1 is 100%, what will be the probability of category 2? Anybody? Very simple. Please answer this question. And I had already answered this question.
1 minus 5.
1 minus 1 is equal to 0. I told you the probability of
1 minus 3.
1 minus 1 is equal to 0. So now put this value here and calculate the entropy. So minus P ka value 1, log of 1 base 2, Q ka value 0. So 0 into anything 0 will be 0, and minus log 1 base 2. This should be minus. So entropy will be 0 because log 1 value is always equal to 0. This is called entropy. Any question? Entropy when the probability of category 1 is 100%. Now similarly, I'm going to make ulta, reverse. Shall we change it? Okay. Now I'm going to make it reverse. Probability of category 1 is equal to 0 and probability of category 2 is equal to 1. So in this case also answer will be same, entropy will be 0. Did you guys understand what I'm trying to say? Hello, hello. Entropy in both the cases will be 0. And how? This is the mathematical formula. So in both the cases, entropy will be minimum. Now, when the maximum, when the probability of both the event is 50-50, means probability of category 1 is equal to 50% and probability of category 2 is equal to also 50%. Then in that case, what will be the entropy? Entropy formula, we are going to write minus P. Put this value here. So minus 1 by 2 log of 1 by 2 base 2 minus 1 by 2 log of 1 by 2 base 2. Now just try to understand this minus become plus. So here is minus minus plus. So minus of 1 by 2 will be 1. So log of 1 by 2 base 2. This will be the answer. So minus here log a by b value will be what? Log a by b value will be log a minus log b. I think these are the things we learn in mathematics. Similarly, here also we are going to write log 1 by 2 log 1 minus log 2 base 2 base 2. I'm going to put this value here, and log 1 value again will be 0 and log 2 value will be 2 by 2 is equal to 1. So entropy will be 1. So entropy will be maximum when the probability of both the category is same, equal. So that's what, this is the formula here. This is the graph you can see. Entropy is 0 when the probability is 0. See, either this 0 or 1. Probability is 0 or 1, the entropy is 0. Can you see this 0? But probability is 50%, the entropy is maximum. This is the formula. This is the graph came from here. Any question? Did we understood all the concept?
So if entropy is Based on the entropy, we need to fix if it's a parent or child based on the entropy value.
Based on the entropy, what you are saying?
We need to fix the data whether it's a parent or child.
Huh. So after entropy calculation, you have to calculate the information gain. I'm coming at this point. I'll take an example also, and then I will show you how to do. Okay, don't worry. Bear with me. Now, as soon as your entropy calculation has been done, then we are going to calculate the information gain. So how to calculate the information gain? Bilkul simple. So information gain formula is entropy of T minus entropy of T of X. I will talk about, don't worry. Let's take an example and solve one problem, and then I can show you how to do it. Okay, and this is called one way of selecting the parent. Then the second way is what? Gini impurity. Gini impurity is also one of the way with which we can calculate the primary node and child node. How the Gini impurity works according to the Wikipedia? According to the Wikipedia, Gini impurity is the measure of how often randomly chosen element from the set could be incorrectly labeled if it has randomly labeled according to the distribution of the label in the subset. So again, it's the same thing, but some different scientist has been developed this metric. So Gini impurity is something like saying the same thing, how randomness is your data set. Entropy is also saying the same thing, degree of randomness. Both the things is same, but way of calculation is quite different. Okay. So what we are trying to do, let's take an example, this example, and we'll solve these things with the Gini impurity and entropy, both the things. Okay. And then we will come on the conclusion. And let's talk about the problem statement first. Problem statement is we have to take a decision whether the student will stay in hostel or not, right? So there is a two predictor. Number one predictor is called class. Number two predictor is a gender. Now my question with you, is it a classification problem or regression problem?
Classification.
Correct. It is a classification problem. Yes, no, it is a classification. So what I have to take a decision I have to take, like whether the student will stay in hostel or not. So to understand whether the student will stay in hostel or not, we have to first come up with the primary node. Which node I have to select that. So let's understand how to do node selected by calculating the Gini impurity. We'll use the above mentioned formula. Gini is equal to 1 minus probability square P of I square, summation of P of I square. So what we are trying to do, first of all, we are selecting the class feature. Okay, let's take this example. Let's take this example. Can anyone take a screenshot? I'm taking my screenshot. Can take with your phone and keep handy. We'll use these things very frequently. I'm taking this screenshot on my phone so that I can use it. Okay. So now coming to define. So let's start with the class, and we will try to get the Gini impurity of the class feature. So let's talk about class only. So inside of class, you can see what are the different classes are there. Class 8, class 8, class 9, class 10, class 11. I think 4 categories are there, right? If you have taken screenshot, 4 categories. So out of class 8, just select the class 8. Forget about 9, 10, 11. Only in class 8, how many are staying in hostel and how many are not staying in hostel? I can see third row is staying in hostel, fourth row is not staying in hostel. So 2 data and 3. First select how many 8 classes are there. 3 classes, I think, right? Total 3 are 8 classes. So out of 3, 1 is staying in hostel, 2 is staying in hostel. Means
1 is not staying.
Correct.
Yes, and 1 no.
So we are going to calculate the Gini impurity, and this is the formula 1 minus summation of both the probability. So similarly, 1 minus summation of this probability of yes 2 by 3 and probability of no is equal to 1 by 3 because 1 is not staying in hostel and out of total 3. So we can calculate the Gini indexing for class 8. Similarly, we can do for the class 9. Can we do this? And you just tell me how many class 9 students are there? I think 3. 1, 2, and 2.
3, sir.
3, yes. And out of 3, again, same answer. 2 is staying in hostel and 1 is not staying in hostel. So same answer, the Gini impurity you can calculate for the class 9 is equal to 4 by 9. Similarly, we can calculate for the class 10 as well. So in class 10, I think 4 students are there. 1, 2, 3, 4. Yes, 4 students are there. Out of 4, 1 is staying in hostel, 3 is not staying in hostel. Yes? So
Yes,
we can
sir.
calculate the Gini indexing for the class 10 and the answer is coming 6 by 6. See, I put a lot of effort to take a screenshot. I wrote down this on my page and paper because these things is not available on the internet so that I can take a photo. I just wrote down in my pen and notebook and I made a slide for you guys. So please observe this effort and just try to solve this. So we can, so now class feature, sorry.
4 in class.
Okay, in class 11 also left, right? Yeah. In class 11, I think 4. 3 is staying in hostel, 1 is not staying. And answer is 6 by 16. So now, here I created a table. 8, 2, 1, no, 9, 2, 1, 10, 1, 3, 11, 3, 4, 3, 1. And we are going to calculate the total value, 14. And yes, staying in hostel, probability this, no staying in hostel, probability this. Now, what we are trying to do, now we are going to calculate weighted sum of Gini imperative for class feature. Okay. Now we are going to calculate what weighted sum of Gini imperatives for class feature. Just a minute. So, so now what we are trying to just focus here, don't go here and there. So Gini impurity for class feature we are going to calculate. So what we are going to say, number of instances divided by total instances into, and now you must ask this question, do we have to remember this formula? No, no, you don't need to remember this formula. These things will get done by the library. I will talk about these things tomorrow session. So number of instances of class 8. This will be class equal to 8. I'm writing here. Into Gini indexing of class is equal to 8. Plus similarly number of instances of class 9 divided by total instances into Gini indexing of class 9. Like this we have to do for all. And total instances of class 8 is what? 3, I think, right? Divided by total instances 14 and Gini indexing of class 8 is what? How much? Just note down. 4 by 9. So here we can write
3 divided by.
Yeah. Yes. So same thing has been written here already. So see, 3 by 14 into 4 by 9. 3 by 14, 4 by 9. 4 by 14, 6 by 16. And total we are going to calculate the Gini indexing is coming 0.404. How it came? You guys can understand this part. Right? Any question till now?
Yes, sir.
Yes. Question do you have? No question. Okay. If yes, then please do let me know. Any question? How it came 404? Hello. Cool. Now similar things we are going to do for the another feature which is called gender. So again, come to this point and gender we have a male, female, and out of male, how many staying in hostel? 5, not staying in hostel, 3. And total is 8. Similarly for female, 3 is staying in hostel, 3 is not staying in hostel. And we can calculate the probability of yes and no, right? And we can calculate the Gini indexing for female, this, and Gini indexing for the male, we can calculate like this. For it. Now we can calculate the Gini indexing for gender How we can calculate? Simple, very simple formula. So simple formula is equal to total number of instances of gender is equal to female divided by total instances into Gini indexing for female. Similarly, total number of instances of gender is equal to male divided by total instances into Gini indexing of male. And we can calculate and we are going to get the result of 482. Now just see the Gini indexing of class is what? How much? 404. And Gini indexing of gender is 482. So we can see Gini indexing of class is less than Gini indexing of gender. So root node is class. Whatever Gini indexing means impurity is less. Gini means impurity. So if it is less means Gini impurity is less in case of class feature. So I can select class as a child parent node and gender will be the child. Now you understood how to do with the help of Gini indexing. Hello, hello, hello. Hello.
Yes, sir.
Yes. And now you must ask, do we have to remember these things? No, no. You have to just do the practice. Okay. So notes already shared. Please go through till now, till here. Go through till here. If you could able to understand this part, then the entropy part I will cover in tomorrow class and the things will be understandable. No doubt at all. Right? Hello? Yes. Please do it, come up with this up to this slide, and then I will talk about the entropy. If you could come up with these things, then it will entropy part will be very easy. And then I can show you the Python implementations. Right? Cool. That's all for today, guys. Thank you. We'll connect tomorrow, and we'll try to cover it.
Sir, how many classes will be there, sir? Like 1 month?
So see, I'm trying to cover means as much as I can. I'm not doing any hurry in any class, not any of the classes. But if you are in hurry, your class is done, completed. You can start searching around it. But yeah, as per my understanding, the class will go another 1 and 2 month, 1 month at least. Yeah. Yeah. But you guys can start looking for now. That's the only thing. Class will go, but you guys can start looking for job now. Start building your resume and start working. Okay?
So, till here the channel has been completed.
Let me stop this recording first, otherwise it will get recorded. Yeah.
Till here, channel has completed.